Hello and welcome back to my channel, students. In this video we'll be discussing questions which were asked on modern physics on 27 January 2024 JEE Mains. Okay, a small disclaimer, students. These questions have been picked from various sites and they are all memory based questions. Okay, so they are not authentic enough, but definitely we can rely on the type of questions, the nature of the questions, the level of difficulty and all. Just to get an idea regarding all this, we are posting these videos. Okay, students, particularly for those students who will be taking JEE Mains for the first time, because many students, they had skipped the January attempt. They did not attend the January attempt just because they were more, engrossed in preparation for their 12th board exams. So many students are taking this exam for the first time. So in such a case, this will be beneficial for those students who are taking the JEE Mains for the first time, because they want to get exactly an idea what kind of questions they are going to face in the actual exam. So this will give you a pretty good idea regarding the exact nature of question. Alright, students, right. So this is the last video of this sequence, students. Okay, next you will get the other videos which were based on questions asked on other dates of January, right. So coming to question 54, the radius of third stationary orbit of electron for Bohr's orbit is r. The radius of fourth stationary orbit will be. Now students, it's very simple. Suppose you must be knowing that the radius of nth orbit for any hydrogen-like atom is given by this hydrogen-like ion. Now in that case, you can see, since it is clearly given that Bohr's atom. So Bohr's atom means you can simply take it as hydrogen. So you can see, Rn is proportional to. So Rn is proportional to n square, you can write. Okay. So we require the radius for fourth orbit, whereas the radius of third orbit is given. So we have 4 by 3 whole square. That is 16 by 9. So 16 by 9 times. This is the final answer. Now suppose students you forget this result, then what you will do? You can derive in the exam all immediately, because very simple. Just the first law is the Rutherford's law, which states that the force acting on the electron, the electrostatic force acting on the electron provides the centripetal force required for its circular motion around the nucleus. So this is the electrostatic force, students, where Z is the atomic number, there are Z protons, so Ze will be the protonic charge of the nucleus and E is the electronic charge. So this is how you get it. So you cancel this R, okay, and you take this R to this side. So one equation is mv square R is K is 1 by 4 pi epsilon 0, Z is square. This one equation. This is according to Rutherford's law. According to Bohr's postulate, the angular momentum of the electron is conserved, is quantized in fact, and one quantity is h by 2 pi. So n is the principal quantum number. This is the other equation, students. Okay. So you can obtain R if you square this and divide. If you square equation 2 and divide, you will get this result. Upon squaring, you will get n square upon z. Okay, moving on to the next question, students. A convex lens of focal length 40 cm forms an image of an extended source of light on a photoelectric cell. A current I is produced. The lens is replaced by another convex lens having the same diameter but focal length 20 cm. The photoelectric current now is. Now, students, you know, the photoelectric current, basically the charge, rate of flow of charge passing in the setup, rate of flow of charge, that is number of, it will be proportional to the number of charged particles passing, and this number of charged particles is nothing but photoelectrons. So the rate at which photoelectrons are emitted, that will decide the electric current, and that is decided by the intensity, because intensity will be proportional to the number of photons striking the cell, and number of photons striking the cell will proportionately eject number of electrons during the photoelectric effect. So basically we are interested only in the change in intensity of light. So see here students, in the first case it is given that the lens has a focal length of 40 cm. So a parallel beam of rays is incident here. So it will be focused at a distance 40 cm. So here you have the what photoelectric cell is here. So whatever light is coming in this area, suppose intensity of light is I and area of the lens is A, then the amount of light incident per unit time here, that is the energy incident per unit time, will be intensity multiplied by area. So the rate at which energy is incident, okay, per unit time. So on that basis, proportionately the number of photoelectrons will be ejected. In the second case, they have given that it has been replaced by another another lens of the same diameter. So that means intensity of light is already same, even the area is also same. But the only difference is it is at a distance 20 cm. So it doesn't matter, you can see area is same. So the energy incident per unit time is still the same. Because unless and until you disturb this cross-section area of the lens, intensity, the energy incident per unit time will not change. So that means the same amount of light is incident per unit area on this cell. So accordingly, same number of photoelectrons must be ejected. So the photoelectric current must remain same. We will go with option 4. Then coming to question 56, the atomic mass of C12 is this and that of C13 is this. The required energy to remove a neutron from this, if mass of neutron is this. So here you see students, the C13 isotope, when you add certain energy, okay, then it will give rise to C12 isotope and a separate neutron. You will get a separate neutron. This is the required distance. Now this mass, now here atomic mass is given as 13.00, whatever is this. I won't write because it's wastage of time. For now I take this as mass of this 13 and this is mass of this 12 and mass of the nucleus, mass of neutron, sorry. So the required energy to remove a neutron. So if you balance the masses, that is mass plus energy, you will get the required answer. If you balance the mass plus energy, you will get the answer. So this side you have 13 point, what will be the thing? I'll take this energy as E. So E will be mass of C12 isotope plus mass of neutron minus mass of C13 isotope. So mass of C12 isotope is this, mass of neutron is this. So if you combine them, these two masses, we have 13.008665. So 8665 minus mass of neutron is 13.003354. Okay, students. So here we have 8665 and minus 3354. So basically we will be getting 0.005311 atomic mass units. Okay. Now we have to obtain this in million electron volt. As you know, student, a mass of 1 mu is equivalent to 931.5 million electron volt. So the required energy will be This delta E will be, this is 0.005311 atomic mass unit multiplied by 931.5 million electron volt. Okay, students. So this is roughly, I am writing this as 5 by 1000. Okay, slightly more than 5, but I am taking 5 only. I have decreased, and here I will be increasing. I will take this as 1000. So roughly it should be close to 5. So any figure which is close to 5 should be our answer. Students, be careful. There's a 6.25 million electron volt option also close to this, but you have to take a calculative risk. If you have time, do check it actually, because you should not take risk. If you don't have time, then certainly you can go with this kind of manipulation, we can say. So the answer close to 5 million electron volt was 4.95. So that is the correct answer. Moving on to the next question, students. The threshold frequency of a metal with work function this much is very simple. Now work function, we know work function is the minimum energy required to generate photoelectrons, and if that be the energy of a photon, then it will be h into nu. So this is 6.63 electron volt to be converted into joule by multiplying by 1.6 into 10 power minus 19, and h is around 6.625 into 10 power minus 34 joule second. So you get frequency. So therefore, so approximately what we'll do, students, we'll cancel this and we are left with 1.6 into this 10 power 34 comes this side, so 34 minus 19, this much hertz. So 34 minus 19 is 15, right? So 1.6 into 10 power minus 15 is the correct answer. Moving on to the next question. An object is placed in a medium of refractive index 3. An electromagnetic wave of intensity this much falls normally on the object and it is absorbed. So you can note that it is completely absorbed. So the radiation pressure of the object would be. Now students, there is a simple formula for radiation pressure. Radiation pressure for completely absorbing what you call this thing, surfaces. You have simply intensity by speed of light. Okay, but remember, since the medium has changed, so you have to take the appropriate speed of light in that medium, which I can write speed of light in vacuum upon mu. Speed of light in any medium is speed of light in vacuum upon mu. So intensity is given as 6 into 10 to the power 8 watt per meter square, which is SI unit of course. This is 3 into 10 power 8 meters per second into refractive index is 3. Even though refractive index cannot be 3, but they have given. As I told you students, it's purely memory based. Okay. In the books and all, it's clearly mentioned that diamond has the maximum refractive index, and it might go somewhere close to 2 point something. So there is no substance in my knowledge whose refractive index is 3. But anyway, they have given. We have to take it. Or it's a memory based question. Maybe the student could not reproduce it properly. So finally, we have 6 Newton per meter square. This is the correct answer, students, as per the given data. Then coming to section B, in a nuclear fission process, a high mass nuclide A approximately 236 with binding energy 7.6 million electron volt per nucleon dissociated into middle mass nucleus approximately A equal to 1118 having binding energy of this much. So the energy released is. Now students, in these kind of questions what happens, in these kind of questions, whenever there is an energy release, certainly there has to be a mass defect. That means original mass if you take will be more than the final mass. Original mass means mass of the reactants, whereas mass of products means the mass which is obtained after the nuclear reaction. So reactants gives rise to products plus energy. So this energy can be obtained as binding energy of reactants, binding energy of products minus binding energy of reactants. Because in order to break the reactants into individual components, that is neutrons and protons, they'll require energy. So they'll absorb energy. Whereas when products are formed from individual nucleons, they release energy. So the energy will be released. So net energy released will be energy released minus energy absorbed. So reactants absorb energy in order to dissociate into individual nucleons, and products release energy when they form the nucleus from individual nucleons. So here this is per nucleon, it is 7.6 million electron volt multiplied by 236 to get the total. Similarly here it is 1180 per nucleon, it is 8.6. Okay students. Now this is 1180 is half of 236. Is it? But as you know, this should get divided into two parts. A heavy nucleus should get divided into two parts. So there will be two. So here product is this. So 8.6 into 118 into 2, because there will be two nuclides, because 236 will give rise to 118 and 118 two times. Whereas for reactant it is only one nucleus. So that is 7.6 into 236. So this is also 236. You can take 236 common, students. So 236 million electron volt multiplied by 8.6 minus 7.6 is 1. So exactly 236 million electron volt is the answer. You have to be careful, students, here, okay? Right. So moving on to the last question of this series. If Rydberg's constant is R, the longest wavelength of radiation in Paschen series will be. Alright. So here you know, students, Paschen series. For Paschen series, okay, 1 by wavelength, that is the wave number, is equal to Rydberg constant into what? 1 upon. First one is Lyman, second is Balmer, third is Paschen, fourth is Brackett, and fifth is Pfund. So Paschen is third. So it has to land up on the third from any orbit higher than 3, that is can be 4, 5, 6, etc. etc. So in order to have longest wavelength, the energy should be minimum, students. Longest wavelength would mean minimum energy, and minimum energy would mean the jumping of the electron from just the neighboring orbit. Neighboring orbit of 3 will be 4. So therefore the longest wavelength will be this. So 1 by 3 square minus 1 by 4 square. So this is 9, 1 by 9 minus 1 by 16. So therefore R, this is 9 into 16, 7. So therefore, if you take the reciprocal, you will have 9 16s are 9 into 4 into 4. So 9 into 16 is 144. So 144 by 7 r is 144. So this is 144 answer. Okay students, because they are asking the value of alpha, total value is alpha by 7 r, so alpha is 144. That's all students in this video. Thank you so much for watching my channel.